Hi everyone, it's me again, and I am here to teach you geometric sequence finding the indicated term or finding the nth term in a geometric sequence. Okay, so let's begin with a review about what do we mean by a sequence, specifically a number sequence. A sequence is a finite or infinite list of terms of numbers arranged in a definite order. That is, there is a rule by which each term after the first may be found. Okay? So just like last lesson we had arithmetic sequence, this time we will be having a geometric sequence. Now, what is a geometric sequence? It is a sequence of numbers that follows a pattern where the next term is found by multiplying by a constant called the common ratio. So the question here is what makes a sequence geometric is because of the common ratio. Now, if you remember back in our previous lesson, which is arithmetic sequence, what makes an arithmetic sequence arithmetic is because of the common difference. So for the geometric sequence it's the common ratio or the R, small letter R. Now, which of the following are examples of geometric sequence? Just to give you an example. So to find R, what we will do is we'll divide any two succeeding terms. That means negative 6 divided by 2. What is that? Negative 6 divided by 2 is equal to negative 3. 18 divided by negative 6 is equal to negative 3. Negative 54 divided by 18 is also equal to negative 3. So, as you can see, we have here what we call common ratio. So we will consider letter A as our geometric sequence. What about B? So negative 1 divided by 1 is negative 1. 1 divided by negative 1 is negative 1. Negative 1 divided by 1 is negative 1. 1 divided by negative 1 is still negative 1. So letter B is an arithmetic sequence. Now let's try the third one, letter C. 10 divided by 5 is equal to 2. 20 divided by 10 is equal to 2. But 30 divided by 20 is 3 over 2. So here we can see that there's no common ratio between the terms. So we will not consider letter C as our geometric sequence. But what letter D? Let's try letter D. 1 divided by 1 half is equal to 2, right? 2 divided by 1 is equal to 2. 4 divided by 2 is equal to 2. So therefore, letter D is a geometric sequence. Let's go to the next slide. Here we have 16, 8, 4, and 2. So let's divide any two succeeding terms. 8 divided by 16, I think that's 1 half. 4 divided by 8, I think that's also 1 half. 2 divided by 4, that is still 1 half. So letter E is an arithmetic sequence. Let's try letter F. 6 divided by 3 is equal to 2. 9 divided by 6 is, I think that's 3 over 2. So there's no need for us to continue this. Letter F is not a geometric sequence. Let's try letter G. 1 over negative 4 is negative 1/4. Negative 1/4 divided by 1 is negative 1/4. 1 over 16. Okay, that's 1 over 16. Okay, divided by negative 1/4. Will that be equal to negative 1/4? Oh, what happened? Okay, I will give you time to think about this. So what's that? What is 1 over 16 divided by negative 1/4? That is right. It's still negative 1/4, right? It's still negative 1/4. Okay, so we will consider that an example of a geometric sequence. So for those of you who are curious, how did I get that negative 1/4? Well, just multiply 4 and 1. That will be your numerator. So that's 4. Multiply 16 and 1. That will be your denominator. Simplify that. It's negative 1/4. Okay, letter H. Is this an example of geometric sequence? Let's see. 1/2 divided by, so 1/2 divided by 1/4. What is that? Okay, so let's apply what I did here. Okay, 1/2 divided by 1/4. Let's apply what we did here. Okay, what I did here. So this is 1 times 4 is 4. Then 2 times 1 is 2. That's equal to 2. So this is 2, right? 1 divided by 1/2. 1 divided by 1/2. Okay, that's 2 over 1, right? It's 2 over 1. How about 4 divided by 1? That's obvious. That's 4. So therefore, letter H is not an example of geometric sequence. Okay? So let's go to the first example. What is the 13th term in the sequence 3, 6, 12, and 24? So for this one, we have a formula, and this is an equals a sub 1 times r, which is the common ratio raised to n minus 1. So an is basically our indicated term. That's the number of term that we need to find. A1 is our first term, and r is the ratio. N is the number of terms in the sequence. So let's find A1, let's find R, let's find N. A1 is 3. R is 6 divided by 3, which is equal to 2. And our N is this. Okay. AN is the last term of this, is the 13th term of the sequence, and we need to find that. So this will be 3 times 2 raised to 13 minus 1. 13 minus 1 is 12. So here, you're not going to multiply 2 times 3. No, you got to solve 2 raised to 12 first. So that's 4,096. Multiply that to 3, and that will give us 12,288. Okay, let's go to the next example. Find the 11th term in the sequence -1, 4, -16, and 64. So this is our formula. That means we need to find A1, the first term of the sequence. We're talking about -1. We need to find R. R is the common ratio of the sequence. So to solve for R, that's second divided by the first, and that will give us -4. And then N is this. That's the indicated term. So now we have this, right? So 11 minus 1 is equal to 10. -4 raised to 10, you got to use that parenthesis if you're going to use calculator. So it will be 1,048,576 times -1. That would be negative. Okay. So everything is just, you can use calculator there. It's going to be easy. Let's go to the, is this the last one? Yeah, I think this is the last one. Okay. So what is the, find a sub 9. So basically we're asking about the ninth term of the sequence of 8, 4, 2, 1. This is our formula. We need to find the first term. That's 8. That's our A1. We need to find R. R is second minus the divided by the first, and that is 1/2. That's our R. N is this. Okay, so that will give us this one. And then 9 minus 1 is obviously 8. So here we will use the loss of exponent. Distribute that 8 to both 8 and 1 and 2. Oh. Okay, excuse me. There. So 1 raised to 8 is equal to 1. 2 raised to 8 is equal to 256. Let's multiply those two. Okay, that's 8 times 1 is 8 over 256. But here, you got to simplify that because I think 256 is divisible by 8 and also 8 is divisible by 8. So the final answer is 1 over 32. So that's how you find the indicated term in a geometric sequence. Just use the formula, find the first term, find the common ratio and the indicated term, plug them in the formula, and then just simplify or evaluate the problem. Okay? Thank you for watching, and have a great day.